Grouping half a dozen AI agents together to solve a complex problem often scales the noise faster than the intelligence. Without a hierarchy to filter communication, autonomous systems collapse into a state of operational entropy, breaking down much faster than they can solve the task at hand. Google DeepMind recently measured the exact failure rates of these unmanaged groups, which they appropriately labeled bags of agents, in real-world environments. Unstructured agents actively multiply mistakes. Operating without an organizational chart amplifies errors by 17 times through context contamination. If one agent hallucinates bad data, it feeds directly into its peers, instantly corrupting their logic. In a live production environment, this triggers a cascading failure. The system gets caught in a feedback loop of bad data, burning through computational resources and thousands of dollars in a matter of hours. To safely deploy multiple agents, you have to abandon the bag of agents approach and engineer structured topologies. You must give the AI clear boundaries for how it communicates. Without a strict structural framework, adding more compute power fails to solve the problem. It turns an expensive tool into a highly unpredictable operational liability. The baseline for structuring AI workflows starts with strictly linear tasks. If you are translating documents or summarizing thousands of daily logs, you require a sequential pipeline. This operates like a factory assembly line. Data enters one end, the first agent performs its specific isolated task, and then hands the work directly to the next agent down the line until the output is complete. But assembly lines are rigid. If a task requires dynamic problem-solving or complex research, a strict linear sequence fails because it cannot route around unexpected roadblocks. For exploratory tasks, engineers use the hierarchical supervisor-worker model. This introduces dynamic delegation to the system. In this topology, a central supervisor agent acts as a tech lead. It analyzes the overarching problem, breaks it into individual components, and then routes those subtasks to specialized worker agents based on their exact capabilities. We can see the impact of this structure in Klarna's deployment of a hierarchical Langgraph topology across their customer service network. Rather than letting individual agents guess how to handle customer issues, they used this strict multi-agent structure to triage and manage 2.3 million active customer chats. By delegating intents to specific functional workers, that AI system did the work of 700 human employees, saving the company $60 million. Clearly defined task boundaries and a strict chain of command are what actually turned theoretical AI capabilities into massive, measurable return on investment. Data processing and customer routing have clear mathematical endpoints, but the challenge gets harder when a system requires subjective decision-making, where there is no single deterministic correct answer to grade the AI against. To manage this ambiguity, developers use the multi-agent debate pattern. This framework simulates adversarial human review to pressure test different solutions. You assign contrasting personas to the worker agents. An optimist generates a bolt strategy, a skeptic attacks it for flaws, and a pragmatist seeks realistic compromise. Above them sits a master judge agent. Its sole function is to observe the competing arguments from the workers and synthesize them into a final balanced output. But standard debate patterns carry a risk. Agents frequently get trapped arguing in endless loops, wasting immense computational resources without reaching a conclusion. The Rank Adaptive Cross-Round Protocol, or RACR, stops this recursive waste by changing how the system processes disagreements. Instead of letting the agents argue indefinitely, the judge agent dynamically ranks the inputs and actively silences the weakest arguments mid-debate. By severing the weakest conversation threads in real time, the protocol forces rapid consensus and prevents runaway token costs. This highlights a requirement for modern AI systems. Autonomous agents must be bound by a strict organizational chart. If you do not give them a strict one, their immense processing power will simply amplify their own mistakes.